Hello, Algebra 2 folks, and welcome to functions. This is going to be kind of an algebra review, so we'll get started. In Algebra 2, though, we are going to focus on more complex functions than you learned in Algebra 1. So even though you learned functions in Algebra 1, we're going to focus a little bit more on more complex or difficult ones. So if you look at the first graph, it's the blue graph, and if you can see, that is this one right here. Okay, that's a sine wave. That's kind of a little bit more complex of a function than what you learned in Algebra 1. And another function that we're going to focus on later on in the year is the red function here, and that's called a log, or a logarithmic function. So the big idea today is not that you can do anything with these sine waves or logarithmic functions yet, but just in a sense of what is a function. So we're going to just figure out what a function is today, and then we'll be able to do a little bit more later on throughout the whole year. So our learning targets today are to make sure that you know how to state the domain and range of a relation, and that you can determine if a relation is a function. All right, so please put those in your notes. This you don't have to put in your notes, but when I'm talking about a function, I want you to view it like a function machine. We have some input values that are our x values that we are going to input into our machine. And when we put it in our machine and we evaluate it, then we will get our output values. So if I take these input values and input them into our rule or our machine says we want 2x plus 1. If I put 1 in for x, 2 in for x, 3 in for x, and 4 in for x, I am then going to get our output values, like our y's, our answers, 3, 5, 7, and 9, because 2 times 1 plus 1 is 3, 2 times 2 plus 1 is 5, 3 times 2 plus 1 is 7, 4 times 2 plus 1 is 9. Okay, so our input is what we're putting into our machine, and our outputs is what we're getting. I do need you to write this down. This is a relation, so I want you to know that a relation is a set of ordered pairs with a domain. That's your x or input values, and it has a range. That's your y or your output values. So in this function machine, our x or our domain would be 1, 2, 3, and 4, and our output values or our range for this machine would be 3, 5, 7, and 9. Okay? I want you to also put this mathematical definition of what a function is. So a relation is any ordered pairs. Okay? A function has to be a relation, but the relation is where each value in the domain is paired with exactly one range value. So we need to kind of talk about this a little bit more. And the way I have that set up, and you don't have to write this down, but is what I want you to consider is that we have a vending machine. And the vending machine has all different sort of Gatorades in this case, some tea, and some water. Okay? 2 buttons can lead to the same output. So these 2 buttons are both Gatorades, red Gatorades. If I push this button or this button, I should get a red Gatorade. These 2 buttons represent blue Gatorade, okay? And so on and so forth, okay? The input values are the buttons you press, and the output button is the beverage that comes out. So if I were to push this button or this button, I will get a blue Gatorade. Okay? 2 buttons, like I said, can lead to the same output. Here's my question. If I were to push 1 button, could I get 2 different drinks or outputs. Okay, so the input are the buttons that you press, the output is the beverage you get. If I were to push one button, would I get two different types of Gatorade or water? Let's take the regular water here. If I were to push this button right here, I would hope to get water. But if I push that button and got blue Gatorade, I would say this vending machine, this machine is not functional because it's not giving me what I asked it to give me. It gave me a different thing than I expected. So when you're thinking about a function, think of it as if I push the button and I get two different answers, but I was really supposed to only get water, but I got water and Gatorade, then the machine is broken and it's not a function. Okay, here are some real life examples of the difference between a function and not a function. So if I were going to talk about a function, I could say that North Dakota has one capital, Bismarck. South Dakota has one capital, Pierre. Minnesota has one capital, St. Paul. So every state has one capital. If states started having two capitals, two different capitals, then that wouldn't be a function. So this is a function because every state has one capital. If I talk about a non-function, we can talk about state and senators. North Dakota has two senators, state senators. We have Hoeven and Heidi Heitkamp. Okay, so that is a non-function because one state having two senators would say that's non-functioning. It's like the machine. If I have water and I expect to get water, but all of a sudden the blue Gatorade comes out, that's not a function. Okay? Make sure that you write that down. It's a good life example. Now I want to talk about examples of ordered pairs. Okay, so I'm going to give you a relation. I want you to tell me the domain and range, and then I want you to tell me if it's a relation, is a function. So we know every one of these examples that I'm going to give you right now are relations, okay, because I'm going to give you 5 problems, and in those 5 problems, you're all going to have inputs and outputs, and you're going to be able to tell me domain and range. So we know every single one of these that I'm giving you is a relation. But what I want to be able to you to determine is that if the relation is a function, okay? So let's look at the first example. If I give you an example and I give it to you with a table, in form of a table, you should be able to tell me the input values, the output values, and if it's a function. So remember, the input values are your x values, okay? So that's also called your domain. So if I were going to tell you what the domain of this relation was, I would say the domain is 0, 1, 2, 3. And yes, you need to have those little squiggly lines, and you need to tell me that it's domain. So D colon squiggly 0, 1, 2, 3, 4. Now, if I were going to ask you what the range was, the range are your output values or your y values. So R would be -7, -4, -1, and 2. And it's best if you put them in numerical order. Now let's determine if this is a function. Now, 0 goes to 2. Does 0 go to anything else? No. 1 goes to -1. Does 1 go to anything else? No. 2 goes to -4. Does 2 go to anything else? No. 3 goes to -7, and there isn't another 3. So I would say that this is a function because every x value has exactly one y value. Okay, now that's when I look at in a form of a table. What if I look at as a form of mapping? Mapping is another way to draw a relation. So my inputs are 1, 2, 3, 4. My outputs are D, B, C. What is the domain? The domain is 1, 2, 3, 4 because the inputs are your X, and that's your domain, and the Y's are your range, and that would be B, C, D. Again, numerical order or alphabetical order is the best that we can do here. Now, is this a function? Okay, I've got 1 going to D. Okay, so I have Pop Machine giving me Diet Coke. I have button number 2 giving me blue Gatorade, and I've got button number 3 giving me carrot juice, and button number 4 giving me carrot juice. Remember, we can have 2 buttons that give us the same thing. So this is a function. Okay, now let's look at this map. Let's determine the domain and the range. So first, the domain would be your X values. Okay, your X values are -8, -5, and 7. Your range is your Y values, -6, 1, 2, 3. And now I'm going to ask you if this is a function. So I have -8, 1 button, giving me 2 outcomes. 1 button can't give me 2 outcomes. I either push the button and I get a diet soda, or I push the button and I get blue Gatorade. I'll never know when I push the button what I'll get, so it's a broken machine. This is not a function. Okay, let's do 2 more, but this time I'm going to just write them as ordered pairs. Okay, and sometimes with ordered pairs it makes it really hard to just look at and know. So my suggestion is to map it. Put it in a mapping sort of way and be able to determine whether you'll be able to determine if it's a function or not very easily. So I'm going to put my inputs in the first. These are my X values, or my inputs. So that's -2, 0, 4, and 5. And then I'm going to put my Y's, which are my outputs, in the second one. And that's 0.5, 2.5, 6.5, and 2.5. And then I'm going to draw arrows. So -2 goes to 0.5, 0 goes to 2.5, 4 goes to 6.5, and 5 goes to 2.5. So your domain is -2, 0, 4, 5. Your range is 0.5, 2.5, and 6.5. And now can you tell me if this is a function? And I would say, yes, it is a function, because every input has exactly 1 Y. So 1 button gives us 1 thing, 1 button gives us 1 thing. Oh, the same button gives us that as well, but that's okay. I can have 2 blue Gatorade buttons and still get blue Gatorade. Okay, and then 4 is giving me 6.5. This is a function. Okay, so let's do the same thing when I get a set of ordered pairs. I'm going to put them in a mapping. I'm going to say my domain is my inputs. That's my X values. My range is my Y's, and I'm going to map it. I'm going to draw an arrow to where things should go. So 6 goes to 5, 4 goes to 3, 6 goes to 4, and 5 goes to 8. Now my domain is 4, 5, 6. My range is 3, 4, 5, 8. And we know it's a relation, but is the relation a function? Well, 4 goes to 3, 5 goes to 8, but 6 goes to 4 and 5. 1 button giving me 2 different outcomes. That's a broken machine, so that would not be a function. All right, thank you for taking good notes, and that's all I have for you today, and we'll see you again tomorrow.